Hello all, welcome back. Today's video is about an AI program that would use an artificial neural network to identify which traffic sign is appearing in a given photograph, which you might imagine is pretty useful in the development of self-driving cars. So this GDSRB is my massive dataset of directory, which contains as many as 26,000 of images of road signs to train and test my network. And then all these 26,000 are images all binds down to these 43 different categories of road signs. So without any further ado, let's run our program. Python traffic apply GTSB. Now our AI is supposed to be starting to load the images and being formatted into a particular format that our libraries, scikit-learn and TensorFlow expect. Alright, we see the summary here, and now our model is being fitted on training data. Basically, our AI program is learning how to distinguish correctly between road signs. Alright, it's taking long and it's kind of normal. And at the first epoch or first time of learning, this percentage is how much portion of the images that our program can correctly label. So we get to see. And now we see that at the first time of learning, our AI program is able to correctly identify 43% of the images, which is not a good percentage, but we'll get to see that our AI is able to learn progressively, and the program will be only better after every epoch or every training. Now we can see that the accuracy has improved significantly. So alright, while waiting for this to have a grasp of with which layers my network is using, let's have a peek into code implementation. As can be seen, I've used two layers for convolutional and pooling layer in order to further reduce down the size of the input to the neural network. And also, this double convolution and pooling produces more accurate results as far as an experiment. You will see that instead of average pooling, I've used mass pooling here, which turns out to work better with this particular data set. And then I flatten it and I add only one additional layer, hidden layer, because I find that adding more hidden layers doesn't make any improvement. And I chose the dropout rate to be 0.4, which seems pretty compatible with this number of units in this hidden layer, which is 256. Here comes the output layer with the addition function softmax, which is a pretty good function for probability distribution between 43 different categories of road signs. And our program will pick the road sign with, of course, highest probability. Now let's see how our program is doing. Alright, now our program is about to finish learning, and after that we get to see how well the program were able to perform. Alright, now we see that after 10th time of learning, our program is able to predict 96% of the images correctly, which is pretty impressive, I suppose. So yeah, alright, anyway, that's what the functionality of my program is all about. I've documented my experimentation with this program using different parameters like different numbers of kernels and max pooling and average pooling in this readme file, and I've added a link to this readme file in the description down below. So my name is Jaradu and this is CS50.